So recall from last section that f of x was equal to a times b to the x power, right? And the b part was simply our common ratio. And a, what was called our initial value, or basically the value when x is equal to 0. So a represents when x equals 0, otherwise known as the y-intercept. And b represents the common ratio. And you can find that by taking basically f of x plus 1 and dividing it by f of x. So, right, if you know the second term and the first one, that'll also give you your common ratio. The y-intercept when x is 0 is basically 0, and then whatever a is, value of a. So, and let's take a look now at some of the end behavior samples in our guided notes. So you'll notice that as x approaches basically negative infinity, y approaches 0, go in this direction. And as x approaches positive infinity, right, y approaches negative infinity, going down this way. And this arrow simply means as x approaches infinity, f of x, or the value of y, approaches negative infinity. And as x approaches negative infinity, f of x approaches 0. And this symbol is short for approaches. So again, as x travels this direction, right, and that direction is positive infinity, the value of y keeps rising. So the value of y, or f of x, approaches positive infinity. Right? As x goes this way, y goes that way. But as x goes this way, towards negative infinity, where does y go? Closer and closer to 0. So let's from here, let's take a look at some examples with actual numbers and a table and a graph. So here we go. We got our x values, and we're going to try to find our f of x, and the formula is 3 times 3 to the x power. So in this graph, the a, right, is right there, a times b to the x. So a is 3, and b is 3. So from here, you just plug in the various points for x, and you'll get some values for y. So we know, basically, we're going to take 3 times 3 to the negative 2. And then we're going to do 3 times 3 to the negative 1. And then 3 times 3 to the 0. And then 3 times 3 to the first power. And then 3 times 3 to the second power. So as we do that, we're going to get some values, right? And these are all things you can punch into your calculator, and it'll give you all the values as well. So hopefully you can kind of tell the general trend is that basically as x approaches positive infinity, y is going to be approaching positive infinity. And it just simply means as x gets larger, so does y. And now that we've got some values for a couple points, we can put this on a graph. And I already, the end behavior as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches 0. And now we're going to see this in action. So at -2, we're at the point 1/3, somewhere around there. And at -1, we're at the point 1. Oh, I should... So here's the rest of the graph. I accidentally hit the stop record button the last minute or so that I was talking. But basically, here's all the various points of the graph. -2, 1/3, -1, 1. At 0, we're at 3. When x is 1, you're at 9 for the y. When x is 2, you're already at 27 for the y. And basically all you can tell is as x gets larger and larger, so does y. So as x approaches infinity, f of x, or the value of y, approaches infinity. As x approaches the value of negative infinity, right, when it goes the other direction though, y gets smaller and smaller. And it will forever get smaller and smaller, and it approaches 0. And this concept that you're seeing visually is also known as a limit process, and you get to limits actually in pre-calculus and calculus. So you're already looking at right now in Math 1 concepts that get carried over into pre-calculus and calculus. So there you go. And we'll go to the homework packet from here.